This section explains how Hempel and Oppenheim turn the idea of emergence from a property of the world into a hidden, three-place relation in our description of it. What looks like a property of the world is an unbound variable in your description of it. Hempel and Oppenheim take the word emergent, the air of a whole possessing novelty unpredictable from its parts, and show that the predicate is incomplete. Unpredictable relative to what? Bind those three parameters and the mystery dissolves. The first is a theory, call it T. The second is a part relation, call it PT, which says how a whole decomposes into its parts. The third is a class G of attributes over which those parts are characterized. Once they are bound, emergent becomes a sober, three-place index. A characteristic capital W in an object lowercase w is emergent if and only if it cannot be deduced by the theory T from the PT parts of W as characterized over the class G. The metaphysical residue evaporates. Emergence then measures the scope of present knowledge. It is an epistemic index, a record of what our current theory can and cannot deduce, rather than an ontological trait the world carries in itself. What is emergent today loses the status tomorrow. This section explains the deflationary account of emergence that Hempel and Oppenheim built. Emergence looks like a property of a phenomenon. Water's liquidity just is, on its face, something you cannot predict from hydrogen and oxygen. Hempel and Oppenheim's move is to show that the predicate is incomplete. The claim, W, is emergent, secretly carries three suppressed arguments, and once you write them in, the mystery evaporates. A characteristic capital W of a whole, little w, is emergent only relative to three things. First, a theory, capital W, is emergent when it capital G description of the capital PT, which fixes what counts as a piece. Third, an attribute class, capital G, which fixes which properties of the pieces you are handed. The characteristic capital W is emergent when it cannot be deduced through the theory, capital D, from the capital G description of the capital BT, which fixes what counts as a W. So emergence indexes the scope of present knowledge rather than marking an ontological seam in the world. What resists deduction today loses the status tomorrow. The whole anthology starts from this deflation. This section explains why consciousness resists the reduction that every other phenomenon submits to. Every textbook reduction, heat, color, solidity, runs the same move. A phenomenon's surface appearance is causally traced to a microstructure. Then the word is redefined to name the cause and discard the appearance. Heat becomes molecular motion. The feeling is carved off as mere seeming. This redefinition is Searle's primitive, the entire engine of ontological reduction. It costs nothing, only because the discarded appearance lands safely in consciousness. Consciousness is the single case where appearance is the phenomenon, so the carving move has nothing left to carve to. Its irreducibility is therefore a triviality of the method, and physicalism stays intact. Reduction stalls because you cannot redefine away the very thing that redefinition relocates. This part explains why consciousness only looks irreducible. Reduction is never a discovery. It is a redefinition. Heat, color, and solidity all reduce by the same move. Science locates the cause, then carves the subjective appearance off the word and keeps only the cause. Real heat becomes mean, kinetic energy, and the felt warmth is demoted to a mere effect of it. Consciousness resists this move, and the reason is not some special metaphysics. It resists because here the appearance is exactly what we mean. There is no surface to carve away and still have the phenomenon left over. So its irreducibility is trivial. It is an artifact of where we aim the definition, not a crack in the physical world. Causally emergent? Yes. A second substance? No. This section reduces emergence to a single question about laws. Emergence comes down to one question, and the question is about laws rather than about wholes. It asks whether the principle linking the properties of the parts to the property of the whole follows from the lower level laws, or whether it must instead be accepted as fundamental. McLaughlin makes a property emergent in exactly one case, when it supervenes with merely nomological necessity, and when at least one of its supervenience principles is itself a fundamental law. Broad called such a principle a transordinal law. It is underivable from the micro-laws even given all the initial conditions. The intuition that the whole exceeds the sum of its parts is a decoy. Nonlinearity on its own yields only resultants. This converts the dispute between reductive and non-reductive materialism into a checkable criterion. Against that criterion, consciousness stands as the sole surviving candidate. This section explains the two ways causes combine, and why emergence is exactly the second of them. McLaughlin, in Chapter 4, excavates British emergentism, mill through broad, down to one structural fork. When several causes act jointly, either the whole effect is the vector sum of each part's separate contribution, the mode Mill called mechanical, and Lewis called the resultant, or it is something the sum does not give you, the chemical or heteropathic mode, the genuine emergent. Emergence just is the breach of the composition of causes. It is a configurational force that switches on only at a given organization, contributing something no summation over the parts can recover. The chapter's job in Bedau's arc is to sharpen this into a supervenience-based definition, precise enough that the claim mental emerges from physical would, if true, kill every reductive materialism. The definition does this without settling whether the claim is in fact true. This part explains how Wimsatt locates emergence by characterizing its complement rather than emergence itself. Emergence has no clean definition, but its complement does. Wimsatt's move is to stop trying to characterize the whole exceeding its parts and to characterize the negation instead. That negation is aggregativity, the property of being a mere sum. A system property counts as aggregate only when it survives 4 invariances under every decomposition. The 4 are these: shuffling the parts, adding or removing them, decomposing, and then reassembling, and the absence of any cooperative or inhibitory coupling. Almost nothing passes this test. Conservation of mass is the rare paradigm case, so emergence, read as the failure of aggregativity, becomes the generic case rather than the exception. Here is the structural surprise. This detects emergence without opposing reduction, a reductive, mechanistic account of why the parts fail to merely sum is exactly what explains the emergence. Anti-reductionism was never the price of admission. This part explains how Wimsatt defines emergence by defining its opposite. Emergence is what survives when aggregativity fails. Wimsatt inverts the definitional task. Rather than say what emergence is, he characterizes its complement, the mere aggregate. A mere aggregate is a system property that stays invariant under 4 operations on its parts: intersubstitution, addition or subtraction, decomposition, and reaggregation. True aggregativity demands this invariance across all decompositions, and almost nothing meets it. Only the conservation laws qualify: mass, energy, momentum, and charge. So, emergence carries no anti-reductionist mystery. It is the generic case, any property that depends on how the parts are organized. The four conditions then become reductive heuristics. You locate emergence by watching which invariance breaks. The chapter's role in the book's arc is to dissolve the reduction versus emergence war by making emergence the ordinary output of reduction. This part walks through how an emergent property actually comes into being and why the standard argument against emergence never gets a grip on it. Kim's exclusion and downward causation arguments only bite if an emergent property and its base coexist. Supervenience pins the higher property onto an intact lower one, so causing the emergent collapses into causing the base, and the so-called novel causal powers become either redundant or a contradiction with physical closure. Humphreys denies the coexistence. His fusion operation is a real physical interaction, not a conjunction, and not a set formation. It takes two lower-level property instances and consumes them. Inside the fusion, the originals no longer exist as separate entities, their causal powers used up. An emergent is what those components became, rather than something standing atop them. See emergence as consumption rather than coexistence, and every exclusion paradox dissolves on its own. This section explains the fusion theory of emergence. Both arguments against emergence, the exclusion argument and the downward causation argument, break on a single false relation. That relation is supervenience, where the parts persist beneath the whole, simultaneous with it, and available to overdetermine it. Humphreys swaps the relation. Emergence is fusion. Lower-level property instances combine and go out of existence, consumed into a higher-level instance that thereafter acts as an atom. 'Cause nothing co-occurs, nothing overdetermines. Downward causation needs no spooky reaching down because the lower level is simply no longer there. Quantum entanglement is the real specimen. King's College fan vaulting is the contrast that is not fusion. Here is the generative primitive. Ask of any whole whether its parts survive inside it. If they are consumed, you have emergence. This section explains how the doctrine of emergence becomes a claim sharp enough to break. Emergence survives only if you fix what it denies. Kim splits the doctrine into two claims. First, emergents are novel, unpredictable, irreducible from their microbase. Second, emergents wield new causal powers downward onto that base. He makes the first claim constitutive, and the second the thing to be tested. The criterion is theoretical unpredictability. Knowing a system's total microstructural property and every law governing it still will not yield E, even where inductive prediction succeeds. The chapter's office in the book is to convert a vague honorific into a definition sharp enough to break. Once emergence means irreducibility, the boasted downward causation must answer to the causal closure of the physical, and the two commitments cannot both stand. This section explains how Yagwon Kim frames emergence. Emergence is the residue that supervenience leaves behind. Grant that every property of a system is fixed by its total microstructure, the particles, their intrinsic properties, and the relations configuring them. Most properties follow as resultant, meaning theoretically predictable from that base. Kim's move is to define the emergent purely as what resists this prediction, then ask whether anything further is being claimed. he finds two clusters. The epistemic cluster is the novel, the unpredictable, the irreducible. The metaphysical cluster is the claim of new causal powers, above all, downward causation. Taking only the first as constitutive, he factors emergence into a predictability thesis and a causal thesis, so the second can be tried on its own. The chapter is the framing of an indictment. Non-reductive materialism, today's orthodoxy, is made precise enough to put on trial. This section explains how weak emergence resolves the apparent contradiction at the heart of emergence. Emergence looks contradictory. A macro pattern seems to both depend on and be autonomous from its micro base, transparent and opaque at the same time. Weak emergence dissolves both halves of the paradox. Take the dependence first. Downward causation reduces to ordinary diachronic macro causation. The glider gun fixes the fate of cell 17 by aggregating micro updates over time, so nothing is circular, excluded, or law-breaking. A cause never rewrites the conditions it arose from. It shapes only its own future. Now the autonomy. Autonomy survives exactly where the macro pattern is counterfactually invariant. A glider gun keeps firing under any micro substitution. An accidental glider stream does not. That counterfactual invariance is what makes the macro explanation irreducible, even as the ontology fully reduces. The irreducibility is structural, a fact about the pattern itself, rather than a measure of our ignorance. This section explains Bedau's account of weak emergence. Bedau's wager is to rescue emergence by moving its mystery from substance to computation. The macro is nothing but the micro, ontologically and causally reducible, yet its global behavior admits no shortcut. You derive it only by running the underlying process forward, step by step. That is weak emergence, underivable except by simulation, anchored in the cellular automaton, wholly fixed by its rule, yet unforeseeable without iterating. This dissolves the old paradox of phenomena, both dependent on and autonomous from their base. The dependence is ontological. The autonomy is merely explanatory. Strong emergence, the claim of brute downward causal powers, is conceded real, if anywhere but scientifically idle. The only autonomy you are entitled to is the incompressibility of the trajectory. This section explains what makes a pattern real, and how Dennett builds an ontology on that single criterion. A pattern is real exactly when the data admits a description shorter than its verbatim bitmap. This is Chaitin's randomness. Read backwards. Incompressible means patternless. So any compression below the bitmap is a real pattern, whether or not a perceiver ever concocts it. Dennett's move is to let ontology ride on this single criterion. Beliefs are real to precisely the degree the intentional stance compresses behavior below the neural bitmap. Mild realism is what falls out when reality admits degrees set by compression ratio, rather than a binary as real as electrons test. Consider the chapter's seat in the anthology. The same compression that buys belief. Its reality licenses macro patterns, emergence, as genuinely there without being fundamental. This section explains when a higher level pattern counts as real. A pattern is real exactly to the degree that describing it beats transmitting the raw data. Reality is gradable by compressibility, not a binary of exists or does not exist. Dennett dissolves the forced choice between believing in beliefs and eliminating them. Beliefs are abstracta, like centers of gravity, They earn their reality not by sitting somewhere in the brain, but by the predictive leverage their pattern affords. The intentional stance discerns order that is genuinely there. It is there if, and only if, it licenses compression over the behavioral bitmap. This is the chapter's gift to an emergence anthology, the criterion for when a higher level description is real rather than a useful fiction. At the boundary, randomness reigns, nothing compresses, and there is no pattern to be realist about. This part explains why reductionism runs only one direction and what mechanism gives the hierarchy of the sciences its structure. Reductionism does not invert. Knowing the fundamental laws lets you decompose any system downward. It does not license the converse, rebuilding the world upward from those laws. That converse, the constructionist move, fails the moment scale and complexity enter, and Anderson's wager is that the failure is itself lawful, governed by its own regularities rather than being merely hard, welder neater. At each level, new laws appear, as fundamental as the ones below. Psychology is no more applied physiology than chemistry is applied physics. The chapter's job in the emergence canon is to give that hierarchy a mechanism rather than a slogan. That mechanism is broken symmetry, where the aggregate settles into a state less symmetric than its own governing law. The ammonia molecule is its smallest witness. This section explains why reduction and construction are not inverse maps. That a system decomposes cleanly into fundamental laws. An analysis that is total and reliable never licenses the reverse, that from those laws you could reconstruct the whole. The place where the two directions come apart is broken symmetry. As aggregates cross the limit where n becomes infinitely large, matter undergoes sharp phase transitions into states carrying less symmetry than their own equations of motion. The crystal, the superconductor, the spiral sugar that never inverts. New symmetry, new behavior, rigorously definable only at scale. So each rung of the hierarchy demands its own laws and concepts. Chemistry is not applied physics. The whole becomes qualitatively different from its parts. More is different. This section explains emergence as a measurable distance rather than a property a system possesses. Emergence stops being something a system has and becomes a distance. How far a macroscopic behavior sits from deducibility, given the microscopic specification that generates it. Assad and Packard refuse a binary definition and hand you a yardstick instead. Non-emergent behavior reads straight off the rules. Weakly emergent behavior reads straight off the rules. Weakly emergent behavior reveals itself only in hindsight, after watching. Maximally emergent behavior is never deducible at all. The corollary that bites is this. Emergence is observer relative, in the eye of the beholder, yet it is not vacuous, since any system reaching universal computation must produce the genuinely undeducible. What emerges nests by necessity, structure, then computation, then function. Each one requires the last. This section explains the move Assad and Packard make to recast emergence. Stop asking whether a phenomenon is emergent. Ask instead how deducible its macro-level behavior is from the micro-level specification. That single swap from predicate to gradient is what their chapter does in the book's arc. The swap converts emergence from a property a system has into a coordinate it occupies. The gradient runs from non-emergent, deducible on inspection, to weakly emergent, deducible only in hindsight, to strongly emergent, deducible in theory, but intractable, to maximally emergent, not deducible at all. A second axis asks what emerges: structure first, then computation, then functionality, each nested inside the one before it by necessity. The gradient exposes a boundary. Deducibility is observer relative, so the same glider's read as obvious or astonishing depending on the frame. The scale measures the gap between specification and surprise, a relation between observer and system rather than a fact residing in the system. This part explains how Schelling's segregation model shows a macro pattern diverging from micro preference. Schelling's chapter is Bedau's cleanest specimen of that divergence. Each agent obeys one mild rule: move if fewer than about a third of nearby neighbors share its type. From that rule, the board collapses into near total segregation nobody chose. The discontent threshold stays tolerant while the equilibrium turns extreme. Outcome parts from preference because aggregation composes choices non-linearly. One agent's move re-triggers another's, and the cascade has no counterpart at the individual level. That divergence carries the whole emergence reader in its simplest, paper-runnable form. You cannot read the global structure off the local rule. You must run the interaction and watch it sort itself. This part explains why segregation can arise without any segregationist. Each agent merely tolerating a minority of unlike neighbors, a preference far milder than the outcome it drives, suffices to sort the whole board to near totality. The aggregate has, in Schelling's words, no recognizable counterpart at the level of the individual. This is why Schelling earns a place in an emergence reader. He severs collective result from collective in an emergence reader. He severs collective result from collective intent. The macro pattern is not the sum, nor the image, nor some unseen hand fulfillment of micro preference. It is a structure existing only at the aggregate, generated by local choices blind to it. Now predict the inversion the chapter guards against. The visible order tempts you to read back a strong shared preference that was never there. This section explains how a mild individual preference can produce an extreme collective pattern that no one intended. Each coin wants only a third of its neighbors to match its color. A mild, almost integrationist demand. Let the discontent ones move. Each vacated cell perturbs the neighbors left behind, who then move and perturb theirs. That chain reaction settles on a board where like to unlike ratios reach 3-to-1, 4 times what any coin asked for. No one wanted segregation. Segregation is merely the fixed point the restlessness lands on. The thesis, aggregate pattern is not legible from individual motive. The same packed board forms whether coins seek their own color or merely flee the other. Micro-motive underdetermines macro behavior, and the phrase, "it stands to reason that," quietly. This section explains the lesson Simon draws before committing to hierarchy. Complexity in general buys nothing. That is what Simon extracts from 3 20th century eruptions of the word: holism first, then cybernetics, and now chaos and genetic algorithms, each named something real, yet none yielded a theory, because a frame that fits every system constrains none. Traction appears only where a class of systems carries a strong property, a fulcrum for generalizing. That is the whole point of the survey. It is a clearing operation. Catastrophe, theory, chaos, evolution, cellular automata all get weighed and set aside. They are correct as far as they go, only too thin to build a theory on. What remains is the next chapter's wager. The world's complex systems are predominantly hierarchical, near decomposable. And this one constraint is what finally lets theory be built upward, level by level. This section explains why complexity by itself cannot do explanatory work and where traction actually returns. Complexity as such is too general to carry content. A predicate that holds of everything predicts nothing. Herbert Simon's verdict on 3 successive waves, first holism, then cybernetics, then the cluster of chaos, genetic algorithms, and cellular automata, is that each one paid off in the specific concepts it minted: feedback, negative entropy, the strange attractor, while the grand ambition is feedback, negative entropy, the strange attractor. Traction returns only by restricting to a subclass that carries a strong invariant. The chapter names that invariant and defers it to the next chapter: hierarchy and near decomposability. Underneath all of this sits a deflation. Emergence in the weak sense is merely the relations that are absent from the parts taken in isolation, and it stays fully reductive. The whole exceeds the sum of its parts only because the parts in relation were never in that sum to begin with. This section explains why a correct fundamental theory can explain nothing. The exact Schrödinger equation for everyday matter is true, completely specified by a handful of constants, and useless. It becomes insoluble past about 10 particles. Meanwhile, the things that matter, superconductivity, the quantum Hall plateau, even sound in a solid, are fixed by higher organizing principles like symmetry breaking and localization that owe the equation. Such properties are transcendent. They survive unchanged if the underlying equation is swapped out. Laughlin and Pines name these states quantum protectorates, matter whose low-energy behavior is sealed off from its own microscopics. The payload is this: reduction can succeed completely and reveal nothing. More is different, and the foundation turns empirically unreachable. This section explains why knowing a system's exact microscopic law tells you almost nothing about what matters at larger scales. Knowing the exact microscopic law buys nothing about what matters. The everyday world has its own theory of everything. One quantum equation, a handful of constants, provably correct yet unsolvable past about 10 particles, and the exact macroscopic facts, the Josephson quantum, the quantum Hall plateau, cannot be derived from it at all. They are fixed instead by higher organizing principles, by symmetry breaking and localization, principles that would hold even if the underlying law were swapped out for another. The generator is screened off from its output. Reductionism's victory is Pyrrhic. You reduce everything, and you learn nothing about many things of great importance. Anderson's slogan, "More is different," names the primitive. Emergent law is autonomous, generated by its own principles rather than handed down from the law beneath it. This section asks whether anything is ever genuinely new, and what emergence means once you look closely. Every claimed emergence smuggles in an observer. Chaos is unpredictable to a predictor. A random walk is self-similar to an analyst. The newness lives in whose codebook the pattern was missing, never in the system itself, which marches on under the system itself, which marches on under the same equations whether anyone notices or not. Crutchfield's move is to ask when the system is the observer. A pattern genuinely emerges only when it becomes important within the dynamics, as when market agents price off the price they collectively generate. Call it intrinsic emergence, novelty, with no external referent. The chapter's role in the book is to drain emergence of triviality, since almost anything looks new to someone, by relocating the observer inside. This part explains how Crutchfield reframes novelty by asking who is doing the modeling. Novelty is a relation to whoever models a system. It is not a property the system carries on its own. The question of whether anything is ever truly new dissolves once you ask, new to whom, and answer that question structurally. There are 3 rungs. The first is the intuitive one, where something simply appears. The second is pattern formation, where an outside observer detects organization using a fixed codebook, so any pattern not already in the palette reads as noise. The third is intrinsic emergence, where the evaluator is pushed inside, becoming a sub-process of the system that exploits the emergent pattern, gaining computational capability the system then capitalizes on. The chapter's whole work is that displacement. Close the loop of novelty evaluation inside the dynamics, and newness stops needing an external referent. The receiver moves into the channel. This section explains a test for emergence, built from 3 parts called design, observation, and surprise. The first move is to stop treating emergence as a property the system has and to treat it instead as a verdict. An observer issues. This is the same Gordian cut. Turing made for intelligence transplanted to a new domain. Do not ask what emergence intrinsically is. Ask when a competent observer certifies it. The certificate requires 3 things at once. First, a design, stated in the language of local rules, call it language, L1. Second, an observation of global behavior, stated in a different language, call it language, L2. Third, surprise. The causal bridge from L1 to L2 resists the causal bridge from L1 to L2, resists the observer's reconstruction. Emergence lives in that irreducible gap between 2 descriptions held in one mind. It does not live in the flock, and it does not live in the glider. The chapter's whole job in the book is to make a slippery concept, operant, testable, falsifiable, and revocable, just like the Turing certificate it mimics. This section explains why emergence is best understood as a relation between 2 descriptions rather than a property living inside a system. Emergence stops being a property of the system and becomes a relation between 2 languages describing it. The first language, call it L1, is the one in which the designer wrote the local interactions. The second, L2, is the one in which the observer narrates the global behavior. The system is emergent exactly when the observer, knowing the design completely, still cannot trace the causal link from L1 to L2 without effort, and so is surprised. That surprise is the whole criterion. The move is Turing's. An elusive concept, intelligence or emergence, gets no intrinsic definition. Instead, you operationalize it as a test. The observer administers, certifying it by the gap it opens in a competent mind. Emergence thus lives in the dissonance between L1 and L2, not in the stones of the world. This section lays out the central claim of the chapter on dynamical hierarchies. Each new tier in a layered system is paid for at the bottom, in the primitives, not in the rules. The conjecture of Rasmussen and colleagues, their ansatz, runs like this. Hold the simulation framework fixed, then raising the object complexity of the lowest primitives, water and monomers carrying dipoles and hydrogen bond sites, is necessary and sufficient to make monomers aggregate into polymers, and polymers aggregate into polymers. The chapter's place in the book's arc is to turn vague emergence into a generative dial with a price tag. Its central surprise is the strike against the artificial life dogma, the belief that simple rules yield unbounded complex structure. Higher levels do not come free from clever dynamics. You buy each one with richer atoms. Complexity is front-loaded into the primitives, paid once at the bottom, and merely expressed at every level above. This section explains emergence as something you can build rather than something you argue about. Emergence stops being a philosophical claim and becomes a constructive operator you can run. A property is emergent exactly when it holds of the composite and of none of its parts, and that single predicate, iterated, climbs the whole ladder. Watch the climb in matter. Monomers in water self-assemble into polymers, and elasticity appears. Polymers assemble into micelles, and now there is an inside, an outside, and permeability. Each property is absent one level down. Each is generated only by the collective dynamics of the level above. Here is the move that makes the chapter different from its neighbors. Where the reader's other chapters argue whether emergence is real, this one makes it buildable. It gives a simulable hierarchy where order n is defined purely by novelty over order, n-1. The same ansatz applied recursively yields hyperstructures. This part explains how reductionism survives the concession of emergence. It survives by changing what it claims. Weinberg separates two things. The first is the autonomy of the higher sciences, which he grants fully. Hydrodynamics never dissolves into particle physics. More is different. The second is the direction of explanation, the arrows that, when you ask why repeatedly, converge to one source. The first claim is epistemology, a fact about how inquiry organizes itself. The second claim, which he calls objective reductionism, is ontology, an order inside nature rather than a research program. Newton explaining Kepler anchors the point, both are true, and in formal logic they mutually imply each other. Yet one is felt as more fundamental, that asymmetry is a fact about the logical structure of the universe, not about how physicists behave. The chapter stands as the anthology's reductionist pole. It concedes everything the emergentists observe, while denying the inference they draw from it. This section explains where reductionism actually survives even after every concession to emergence. Reductionism survives every emergentist concession once you relocate where it lives. It does not live in the claim that the sciences dissolve into particle physics. Weinberg grants thermodynamics, chemistry, and biology their irreducible concepts. He even quotes Anderson's line that more is different approvingly. More is different of explanation. Ask why, recursively from anywhere in science, like an unpleasant child, and you descend toward the very small. The arrows of explanation converge to a common source. That convergence is objective reductionism, a claim about nature's logical order, not about how the human enterprise is organized. Newton explaining, Kepler is the anchor. Both are true, and they mutually entail each other in bare formal logic, yet one is unmistakably more fundamental. The anthology's foil, emergence, keeps its concepts but surrenders its ontological autonomy. This part explains what it means to reduce one theory to another, and the single device that makes the reduction possible. When you reduce a theory, you deduce its statements from a wider theory. You never deduce its phenomena, because phenomena assert nothing, so nothing follows from them. When both theories share a vocabulary, the deduction is clean. This is the homogeneous case. Galileo's law follows from Newton's modulo approximation. The interesting case is the vocabulary gap. Terms like heat, entropy, and valence inhabit the reduced law and are absent from the reducer. The device the whole account turns on is the bridge law. A bridge law is an empirical hypothesis that pins the orphan term's extension to a structure in the base theory. Temperature, for instance, is where mean molecular kinetic energy reaches a certain magnitude. It is an empirical hypothesis rather than a logical definition that would explain the term away. That single device is what the chapter is for here. Emergence just is the claim that some bridge law stays brute, a connection that nature merely posits. This section explains Nagel's account of reduction and the standard it sets for emergence. Reduction is deduction across vocabularies. Nagel's first move is to relocate it from things to statements. You never reduce heat, only sentences about heat, since phenomena assert nothing. Once that is fixed, one theory reduces another when its laws follow logically from the reducing one. The sole complication is the alien terms. The lower theory lacks temperature, entropy, valence. These are repaired by bridge laws, each one pairing a term to a lower level condition. Two clauses, then, make up the whole machine: connectability plus derivability. Its office in this anthology is to fix the standard emergence must fail against. A property emerges precisely where no bridge law plus deduction recovers its laws. Nagel weaves the net. Emergence is what slips it. This section explains why a system can obey an exact rule and still be impossible to forecast. Determinism does not buy predictability. A chaotic system obeys an exact rule, yet its future is unforecastable, and the compression that the chapter offers is the reason why. Stretch and fold. The Lorentz attractor does to state space what a baker does to dough. Roll it out so that nearby orbits diverge exponentially. Fold it over since a finite attractor must close on itself. Then repeat. Each iteration drags the unmeasurable lower digits of the initial condition up to macroscopic scale, so the system manufactures information rather than conserving it. The randomness here is real and endogenous. It lives in the gap between an exact law and any finite observer. In the reader's arc, this is the cleanest existence, proof that genuine novelty needs no external input. Pure mechanism suffices. This first part explains how a system can be fully deterministic and still defeat prediction. Determinism and unpredictability stop being opposites, and that is the whole move. A few components under fixed nonlinear rules, with chance nowhere, still generate behavior that no amount of added measurement can predict. This is chaos, where gathering more information does not make the randomness recede. The generative kernel is one geometric operation: stretch and fold on a bounded attractor, the baker kneading dough, the dealer shuffling a deck. Stretching drives neighboring trajectories apart exponentially. Folding keeps them confined. So microscopic uncertainty is pumped up to macroscopic scale, and the past is decoupled from the future. In Bedau's Reader, this is emergence with a mechanism, the whole undeducible from its parts through non-linearity alone, no mystery required. The same kneading predicts turbulence, a dripping faucet, and a heartbeat. This section explains why predicting a physical system can be as slow as living through the system itself. A physical process is a computation, and a prediction is a second computation that races it. The shortcut beats the system only when the predictor is cleverer than the system itself. But once a system can host a universal computer, nothing is cleverer. Its own evolution is already the fastest route to its future. Wolfram names this computational irreducibility. There is no formula, no closed form, no oracle, only direct simulation step by step. The chapter makes a wager. It treats irreducibility as the generic case and reducibility as the rare exception. That move recast the entire predictive ambition of theoretical physics as a fortunate special case, the rare system slow enough to be outrun. Idealized limits of infinite time then become formally undecidable. The future exists, yet no finite proof reaches it. This section explains why some systems cannot be predicted faster than they run themselves. A shortcut is a computation that outpaces the system it predicts. Fewer steps reproduce the same outcome. Wolfram's move starts from one observation. The predictor is itself physical, so it cannot outpace the system whose evolution is already computationally universal. For such systems, the fastest route to step t is to run t steps. Their own evolution is the shortest description of their future. That is computational irreducibility. Wolfram's thesis is that this is generic rather than exotic. Most physical questions admit no closed form, and idealized infinite time versions become formally undecidable. Asking whether a given cellular automaton's pattern will ever die is a halting problem in disguise. In the anthology's arc, this is what weak emergence costs. The behavior is derivable in principle, yet provably unshortcuttable in practice. This section explains why the special sciences do not reduce to physics. Reductivism conflates two claims that Fodor prizes apart. The first is that every event is physical. The second is that every special science kind is a physical kind. The first claim survives. The second fails. A bridge law would have to match a kind like being money to a single physical predicate. But money is realized by coins, by paper, by shells, by dents in cattle, an open disjunction that no physical law quantifies over. That disjunction is not itself a natural kind. It is the Eiffel Tower predicate, writ large. So Gresham's law holds, exceptionless in economics, and reduces to nothing below it. A special science kind is individuated by its role in its own laws, by what it does, by its functional role, rather than its material composition. That role stays invariant across realizers that physics cannot collect into a kind. This section explains how Fodor pulls physicalism apart from reductionism. Fodor severs physicalism from reductionism. Granting that every event is a physical event, the claim called token physicalism does not entail that special science laws reduce to physical ones. Reduction would demand bridge laws, pairing each special science predicate with a physical predicate. But a kind like being money or a psychological state is multiply realized across wildly heterogeneous physical configurations. So its physical correlate is an open disjunction, and a disjunction of unrelated terms, names, no natural kind, and the disjunction of unrelated terms, names no natural kind. The special sciences track real regularities that physics cannot state. This is the anthology's charter for emergence. Higher-level laws are autonomous, and they are autonomous because their kinds float free of any single physical realizer, with no added force required. This part explains supervenience, the asymmetric way one level of features depends on another. No two things can differ in their mental features, or their moral features, or their biological features, without differing somewhere in their physical features. That asymmetric covariation is supervenience. Fix the base, and you fix what rests on it. Vary what rests on it, and you must have varied the base. The surprise is what this omits, determination without deducibility. The upper level is pinned by the lower, yet it need carry no recipe back down. It is a function whose existence is asserted but whose formula is withheld. This is why emergentists reach for it. It lets the mental depend wholly on the physical without reducing to it. Van Cleve's whole definition of emergence is then just one dial. Turn, supervenience holding by nomological necessity, but not by logical necessity. This section explains supervenience as Chalmers builds it. Fix every physical fact and ask what freedom remains. Supervenience names the answer. The B-facts covary with the A-facts so tightly that no two worlds sharing all physical facts can differ in biology, chemistry, or mind. The move is to define dependence as pure determination, no difference above without a difference below, while saying nothing about mechanism, reduction, or cause. That neutrality is the power. It lets Chalmers run one test across every domain at once. Almost everything passes. Once the microphysics is set, juiciness and giraffehood have nowhere left to vary. The chapter exists to build the screen, then isolate the lone candidate that might slick through it. Conscious experience. This section explains the trouble non-reductive physicalism inherits once you stack the world into levels. Replace Descartes' two side-by-side worlds with one world stacked into levels. Microphysics at the bottom, minds high up, each tier composed of the parts below, and you inherit a debt, the bifurcated picture never owed. Kim's thesis runs like this. Non-reductive physicalism wants mental properties to be irreducible yet causally efficacious. But its own two commitments work against that wish. The lower level is causally closed, and the mental merely supervenes. Together they leave the mental nothing to do. A complete physical cause already suffices for any physical effect. So the supervening mental property is excluded, squeezed into an epiphenomenon, a passenger that rides along without steering. The middle position is unstable. It either drifts toward Cartesian closure violation, where the mental reaches in and breaks physical closure, or it collapses back into reduction. No autonomous causal floor survives for an irreducible level. That is the trouble the title names. This section explains Kim's argument against non-reductive physicalism, that it collapses into emergentism and inherits the same wound Descartes left. Kim's argument is accounting over causal slots. Non-reductive physicalism wants four things at once. Everything is physical, mental properties are irreducible, each is realized by a physical base, and all are genuinely efficacious. Kim shows this is emergentism, inheriting Descartes' exact wound. If the physical is causally closed, every physical effect already has a sufficient physical cause, the realizer. The irreducible mental property then arrives at a filled slot, so it does nothing, an epiphenomenon, or it competes over determination, or it breaks closure, a Cartesian relapse. The layered world that replaced the bifurcated world was built to dodge this and cannot. Emergent downward causation is the bill non-reductivism issues itself and can't pay.